including being able to play around with smart contracts, being able to just play around with the protocol and develop different projects, which I find really really useful. Yeah, so so we're going to just cover because I have 1 hour, and we're going to cover the introduction of blockchain to blockchain Ethereum, where I'm just going to take you through what is really Ethereum blockchain. Yeah. Today, when I do my classes, when I teach people when I train individuals or corporates with regard to cryptocurrency investments, I often refer to Ether, which is the cryptocurrency that runs on Ethereum blockchain, and Bitcoin as what I call blue chip cryptocurrencies. Yeah. So therefore, I would refer to Ethereum blockchain and the Bitcoin blockchain as blue chip blockchain protocols, because in my view, these are the core protocols. These protocols have been tested for years. Yeah. And we've seen them resilient to a number of challenges. We've seen them, of course, there are others as well that have shown great use. But the Bitcoin blockchain and Ethereum blockchain, for me, I believe that if you're in the blockchain industry, or if you're into cryptocurrencies, you can't afford to not have some understanding of these two protocols. Because for me, they form the foundation of the blockchain and cryptocurrency as we know it today. Then I'm going to cover smart contracts on Ethereum. Smart contracts, which I really consider a revolutionary idea. Smart contract is a revolutionary idea. And for me, without the concept of smart contracts, I think the adoption of blockchain would totally be limited. Yeah, it wouldn't be interesting. It would be difficult to implement it on any other, on different use cases. That's why I think smart contract is a very useful and a very important element of the blockchain industry. Then I'm going to cover just the use case. I'm going to bring it home to where is Ethereum smart contract being used, yeah, and where are the potential use cases of the Ethereum blockchain. Yeah? I'm just going to give you some links, which I consider resources. Now, something to note, Ethereum blockchain in itself is a very expansive project, yeah, and it has multiple aspects that probably, if you go online, you will be able to find courses on Ethereum that would take several hours, yeah. But what I've done is I'm trying to squeeze all this into this session so that what I'm going to give you is fundamental knowledge, and I'm going to give you that desire to explore more and to learn more, probably in future sessions or by your own, taking on initiative, yeah? Because Ethereum itself, without even exploring any other blockchain, without even thinking about Bitcoin or thinking about the Binance, thinking about Cardano, thinking about the others, the meme coins and the rest, or the other blockchain protocols, yeah? Ethereum blockchain alone, yeah, and smart contracts is enough to give you a career, and is enough is enough to keep you busy, yeah, because Ethereum blockchain is so expansive. So let's see what is really Ethereum blockchain. Yeah, so these I've written mostly for because I believe you will get these slides, and these will help you as you try to expand on your understanding. But really, what is Ethereum? Ethereum blockchain, in my simple definition, is one. The Bitcoin blockchain is the first blockchain that solved the problem, the double spending problem, or what we discussed in the other time, the Byzantine generals problem. Yeah. So Ethereum blockchain, in my view, went ahead. It uses the same solution that is brought about by Satoshi Nakamoto, the solution of decentralization, of distribution, yeah, because it is also a blockchain, which means it is a distributed ledger. But then it makes it possible to utilize blockchain technology to solve multiple other problems other than just transactions, yeah. And when I say transactions, I mean the Bitcoin transactions, the peer-to-peer digital cash, the peer-to-peer transactions involving digital cash. So Ethereum blockchain makes it possible. So it is a decentralized open source platform that makes it possible to create decentralized applications, decentralized autonomous organizations, smart contracts. I mean, you can build enormously a lot of things using smart contracts and using the Ethereum blockchain. I think the figure that is known in the Ethereum blockchain is this young gentleman called Vitalik Buterin, who is a Canadian, a Russian programmer. And I think when he was creating Ethereum, he was 19 years old. That was in when he came up with the white paper, it was in 2013. I think this guy was about 19 years old, yeah? And he has since become one of the stars in the cryptocurrency industry, in the blockchain industry, since it is the second largest cryptocurrency. Of course, the largest cryptocurrency is Bitcoin, whose creator disappeared, and we only know the Satoshi Nakamoto, who is not a real name of a person, but a pseudonym. So what is the second concept that is important to understand is the Ethereum virtual machine. This is especially important if you will be focusing on Ethereum development or smart contract development. Really, the EVM is simply the environment in which all the Ethereum accounts and smart contracts live. Yeah, it is a machine that stands. It is on top of the runs on top of the Ethereum protocol, or rather the software, and it helps. It creates an environment. It is like how do I put it in layman term? It is an interface that stands between that transaction, and I'm going to elaborate it. Probably if I elaborate it with a diagram, it will help you understand it better in the next or the coming slides. The Ethereum gas, probably most of you have heard about gas. I want to send some USDT or Tether, and for me to send Tether, I need to use some gas, yeah? Or I need to perform an Ethereum transaction, but I can't perform that transaction because I need some gas. Those of you who are going to try to develop a smart contract, you're going to need some Ether, yeah, for you to pay gas, for you to pay the gas fee. Really, this fee, especially in the current protocol, in the current consensus protocol, the proof of stake protocol that the Ethereum moved to under the merge, especially in that model, the fee is very important because it is what pays the validators. Yeah, initially validators were rewarded by block reward. These are Ether that were mined, new Ether that were being mined through the mining process. But in the new model, the focus is to pay these validators using this fee. Then what is GUI? This is a denomination of of Ether, yeah, a denomination of Ether, bigger than Wei. So these are some terms that you will interact with, especially when you are doing smart contract development, deployment. You will probably need to understand some of this because these are terms that you will probably use on a daily basis or on a frequent basis if you are going to be a smart contract developer in the process of deployment, in the process of interacting with your smart contract. developing, you will need to understand Gwei and Wei. Yeah, so Wei is the smallest denomination of Ether. Yeah, in Bitcoin we talk about satoshis. Yeah, so Wei is really I think is 18 decimal. So it is 10 power 18. Eh? That's what is equivalent to 1 Ether. Then another important thing that I need you to understand is what we call the Ethereum improvement protocols, or proposals, I mean, which we refer to as the EIPs. If you are doing Ethereum development or diving deep into the technicals of Ethereum, the growth of Ethereum right from the day it started right from the day the first white paper was written, and the second and what we call the yellow paper, and all that happened in 2014, you will have to understand the term EIPs, Ethereum improvement proposals. Ethereum improvement proposals in layman term. Yeah, these are just the proposals or the way through which Ethereum blockchain has transformed, yeah, over the years. Yeah, one, to surmount different challenges. Yeah, like one challenge I can talk about is the DAO hack that happened in I think 2016. The DAO hack was a hack of or a compromise of a decentralized autonomous organization that was built on top of the Ethereum blockchain. Yeah, there are a number of other EIPs that you will that has happened, or rather have happened over the years since the launch of the Ethereum blockchain, and some important ones that really stand out. For instance, of course, the latest one that stands out is the merge, and before the merge we had a number of others which we will also see in the upcoming slides, like the London upgrade. Those are what we call the EIPs. Those are proposals that are made by Ethereum developers, yeah, through a process. There is a process of submitting EIPs. Yeah, so an Ethereum developer can submit a proposal for an improvement to be done on the Ethereum protocol to make it better. That's why it is an improvement. Yeah, so the Ethereum protocol keeps improving by the day. Yeah, so this thing is covering my, let me see. So, okay, really, this is just
Hello,
do you
sir.
mean I was muted?
Yes, sir, you muted yourself.
Oh, sorry. Perhaps when I was moving that thing up. So I'm going to start afresh on this slide, because this slide perhaps is what made me move that up. Yeah, so this just talks about the process of growth of Ethereum since its creation, since Vitalik first published a white paper in 2013. Yeah, we see Gavin Wood introducing a yellow paper in 2014, and then 2014 September, and then in 2015. Those are key years for Ethereum development. And when you look at the EIPs or the Ethereum improvement proposals that have happened over the years of the lifetime of Ethereum, you realize one of the early EIPs was the Frontier. So Frontier goes live July 2015, at block 0. Then one other thing that is important in the history of Ethereum that transformed how Ethereum is developed, it transformed conversations around security of Ethereum protocol, is the DAO hack. You cannot talk about the history of Ethereum without talking about the DAO hack, because this really transformed the way the security of Ethereum protocol is envisioned and is developed. Now, the DAO hack is where a team of hackers compromised the what we call DAO is what we call a decentralized autonomous organization, which means this is an organization that is being run by smart contracts. A good example: imagine any organization you can think of online. Imagine Twitter. Twitter right now has been taken over by Elon Musk. Imagine Elon Musk getting out of the picture and developing multiple smart contracts to make the decisions and to run Twitter. Then somebody comes and hacks one of those smart contracts. Which means they can now run that organization without even Elon Musk. They can move the funds to their own accounts. So that's what happened in 2016 with the DAO hack and a siphon of millions of dollars worth of Ether. Then after that hack, of course, there was a fork. And that's something that I don't know if we covered in the early sessions where we were talking about hard and soft forks. And the fork resulted in another version of Ethereum. If you've heard of Ethereum Classic, Ethereum Classic is another cryptocurrency. So Ethereum Classic is like these developers were on all these validators, or these miners. They were on the same journey, going the same direction right from the start, 2013. Not 2013, but at the point of when the mining began, say 2015. At Frontier, they were all on the same page. Everybody recording these transactions, everybody reaching a consensus on what next block to be added and what is the most relevant block, or what is the most relevant list or chain of blocks, the updated blocks or the updated chain. So they were on the same page. They were in consensus as to which one is the most updated chain. So as they moved along after the DAO hack, now there is a disagreement. There is I'm trying to put it literal so that you understand it. There is a disagreement, and people are like, no, we are going this direction. The others are like, we are going this direction. So this is what we call a hard fork, where it results to a creation of an entirely different path or an entirely different route. So there is a split where a section of the miners say, or the nodes, they say, we are going this direction. Then a section of the nodes say, we are following the original path. We are not changing direction. We are just improving this path, but we are not changing direction. So that is what happened with Ethereum Classic. The creation of Ethereum Classic. One is also a fairly strong cryptocurrency. Then, of course, there are a number of other activities that, if you check the history of Ethereum, you will be able to realize, but I've just highlighted a few. Then there is the Byzantium fork, which moved the reward from 5 to 3. I think that was at, I've not verified this block, but about at block that, is it 43370? Then 2017, those of you who were in the crypto industry in 2017, you must have heard about the hype around CryptoKitties. Yeah, CryptoKitties is one very interesting project that I would advise you to actually note it down. Yeah, and check, learn more. Probably watch a video about CryptoKitties. Yeah, because this, in my view, is one project that really brought a lot of interest. Yeah, a lot of interest into Ethereum, the ability to reproduce these kitties, of course, cats, yeah, the ability to reproduce and the ability to have unique identities on the blockchain. These really elaborated the ability or the capability of Ethereum blockchain to be used in multiple use cases. Yeah, and we will discuss some of the use cases in the coming slides. Then DeFi summer, the total value locked in DeFi. Yeah, you'll meet this term if you are going to learn something about DeFi. DeFi is what we call decentralized finance. Decentralized finance is a wave that came up in 2020. Yeah, just at the beginning of the COVID-19 lockdowns, the wave of DeFi began. Yeah, the wave of DeFi came with a lot of creation of a lot of new cryptocurrencies being created online, and the hype around decentralized exchanges. Decentralized exchanges were there even before 2020, but they were not as famous. In 2020, decentralized exchanges, particularly these two, Uniswap and PancakeSwap, particularly those two, they became very popular because cryptocurrencies were being created almost every hour. A new cryptocurrency was being created. And also the same year, there were a lot of what we call rug pull projects. Yeah, rug pull projects, rug to spell R-U-G, rug pull projects were projects where somebody begins a cryptocurrency, then they create liquidity on PancakeSwap, yeah, or on Uniswap. So Uniswap is if you build the project on Ethereum. PancakeSwap is if you build the project on Binance Smart Chain. However, nowadays it is possible to also wrap these projects. If you build a project on a different protocol like Ethereum, you're able to wrap it and still be able to trade it on PancakeSwap and vice versa. So what happened in 2020 is there were a lot of projects being created. Yeah. And these projects, it is very easy, by the way, and this is something that I tried a lot in 2020, and I'll encourage you to try. It will take you probably 1 hour or 2 hours to create your cryptocurrency. You can create your cryptocurrency in your name and launch it. Yeah. And I would recommend trying it on Binance Smart Chain because Binance Smart Chain has very low fees. Ethereum gas fees are relatively still quite high. If you want to just test a project where you're not going to recover that money, or you're just putting in the money to test or to learn. But I'll encourage you as well to explore it on the Ethereum blockchain. Yeah, it won't be that much expensive. It's worth it, an investment for you to test and understand, especially if you're going to learn smart contracts. You're going to have to deploy one, test it, and all that. You launch it on deploy it on the test net, test it before you deploy it in the Ethereum mainnet. Yeah. So the total value locked is a common term in DeFi. Yeah. And the total value locked means the value that has been locked in a decentralized finance platform. So that increased greatly in 2020. A lot of activities around decentralized finance in 2020. Then December 2020, the Beacon chain. Yeah, the Beacon chain is the Ethereum protocol. Ethereum blockchain protocol that started testing the proof of stake consensus protocol. Yeah. So, before Ethereum moved to proof of stake, they launched a separate chain running on its own. Yeah. Running separately from the Ethereum mainnet. And that separate chain, called the Beacon chain, its purpose was to ensure that before Ethereum mainnet ships to a proof of stake, it is properly tested, all loopholes sealed, and the consensus model, the reward model, everything tested. And that all those tests and all those improvements were done under the Beacon chain. Yeah. Then there was the London hard fork. Yeah, the London hard fork. That's another really EIP that it's important for you to really study at your own time, because and I call it the London upgrade instead of the London hard fork. The London upgrade really changed the way it changed the way gas fees are calculated. Yeah. Then I think this is by far the second most important, in my view. I think there's a third. Is it the Byzantium fork or another fork or another EIP that is also important? But the merge, yeah, where the merge that happened recently in September 2022 is the historic movement of the Ethereum blockchain from proof of work consensus protocol. That is the consensus protocol where mining used to happen, where they used to use a lot of computing power to calculate complex mathematical algorithms for them to be able to validate transactions and add new blocks to the chain. Yeah. But in 2020 September, the Beacon chain, yeah, merged with the Ethereum mainnet, yeah, making it possible that now transactions are being validated, yeah, using the proof of stake consensus protocol. And we are going to see that in the next slide further. Yeah, so let's look at a few comparisons between, and I'm going to move really fast now. Let us see a few comparisons between the Bitcoin and the Ethereum. Of course, the creators we've talked about. There are a number of creators, but the key creators that we hear about is Vitalik Buterin and often Gavin Wood. The date of creation, Bitcoin, of course, January 2009, and July 2015. Those are the dates when they started at block 0. Yeah, those are the days when the mining began. The transactions began on the net. And with regard to platform, we see Bitcoin is a currency focused solution. Yeah. But Ethereum is a platform. You can build currencies on it. You can program anything on it. Yeah, you can build applications on it. Then, with regard to consensus, at the time this was created, Ethereum was still in the process of moving towards proof of stake. But right now, Ethereum has moved to proof of stake. Bitcoin has remained on proof of work. With regard to block time, Bitcoin 10 minutes on average. That depends with also the difficulty levels of the network, and Ethereum 15 seconds on average. Transaction throughput 7 transactions per second, then Ethereum 30 transactions per second. And we did talk about, when we were talking about Ethereum, Bitcoin last session, we did talk about the Lightning Network and how it is helping to make this more scalable. With regard to supply, of course, Bitcoin is at 21 million, has a limited supply. Ethereum has sort of an infinite supply, and very interesting model that you can also learn. But they also introduce some ban, which makes it possible also to maintain that the supply. At Bitcoin, I think we are at about 19 million. Yeah. So I'm not going to cover those way. I already covered that the way is the smallest unit of Ethereum. Yeah. So with regard to the Ether itself, and with regard to dominance, Bitcoin is the most dominant cryptocurrency at about 39–40% thereabout, and Ethereum always moving at around 19%. Bitcoin sometimes moves up to 46% thereabout. So these two are very huge in the cryptocurrency industry. Yeah. So the two of them combined have market cap of over $500 billion. Yeah. At the current market rate. Another important thing for you to study is the Etherscan, which is the Ethereum Block Explorer. So Block Explorer, this is where, remember, the key benefits of blockchain that we've discussed before is that blockchain is transparent, right? And the transparency of blockchain means you can be able, anybody in the public, yeah, can be able to see a transaction, yeah, without asking for any permission. So any of you can go online and go to Etherscan, yeah, and you're taken to the platform and you're able to view the transactions that have happened, even those that are happening right now. Yeah, the transaction that have happened a few seconds ago, you're able to see that transaction in the manner that presented before you on this, the amount of Ether that has been transferred and at what block level and from which wallet to which wallet and all that. That is the level of transparency that it provides on that platform. It doesn't give you the names, of course. And by this, of course, we have some prerequisites. So I believe you have all already have some basic understanding of how blockchain works. Yeah, I'm going to move fast on this also. How the Ethereum blockchain works. Of course, so we have a user who is requesting for ETH at the end of that diagram. At the beginning here, we have a user who is sending that ETH. So he enters the Ether address, the public key of the user. And using his private key, he is able to sign that transaction, yeah. And that transaction, of course, passes through the Ethereum virtual machine, yeah. And going through his wallet, which his wallet, he cannot be able to transact. The point of his wallet is very important because that is where he signs the transaction. That is where his private key functions, yeah. And that is where is able to interact with the other user on the blockchain. Yeah. So you cannot broadcast a transaction if you do not have a wallet that is Ethereum compliant, or that is able to work on the Ethereum network. So the other person as well has an Ethereum wallet and they're able to transact. And so the core of all blockchain transactions, as we have discussed in the previous sessions, is that when the transaction is broadcasted, it is broadcasted to the distributed nodes or distributed validators, right? So right now in the Ethereum blockchain, it is being distributed post proof of stake. It is now being distributed to the validators. Yeah, it initially was being distributed to the miners. So these validators, yeah, are able to validate that transaction before it can move to the user. So another thing that is important for me to cover briefly is with regard to governance. Yeah. And I'm just going to look at the two key cryptos that I'm comparing. There is the Bitcoin blockchain and the Ethereum blockchain. So with regard to governance, we have what we call the off-chain and on-chain governance. Yeah. So governance is really, people often confuse governance with consensus protocol. Consensus protocol is the validation of transactions or the adding of blocks. Yeah. How do the validators or the miners reach a consensus to add a block onto the blockchain? Yeah, whether it's on the Bitcoin blockchain or on the Ethereum blockchain. On the Bitcoin blockchain right now, they reach a consensus through proof of work. You have to prove work. Yeah, you have to solve that complex mathematical algorithm for you to prove that work. So you have to use a lot of computing power to solve that problem. In the Ethereum network right now, you have to prove that you have stake. Yeah, and right now the stake, the amount of stake for you to join the validators, you have to stake at least 32 Ethereum. Yeah, so you have to prove that stake for you to be able to validate those transactions or to participate in the validation process. That is different from governance. Now, when we talk about governance, we are talking about how did Ethereum reach an agreement or a decision to move the Ethereum protocol, the Ethereum blockchain, into proof of stake from proof of work? Who made this decision? Are they the same validators or the same miners? Yeah. Are they the same miners? That is the question. Yeah. Who made that decision? Yeah. To, for instance, the London upgrade, all these Ethereum improvement proposals. Yeah. And Bitcoin as well has improvement proposals. Yeah. They have processes through which the Bitcoin core developers, yeah, are able to make certain decisions, yeah, that aim towards improving the Bitcoin network, the Bitcoin protocol. Now, this governance process, most of it, particularly in the, for instance, in the Ethereum blockchain, because this is what we're focusing on now, actually, most those decisions are done off-chain. Off-chain means they're not done by these validators. They are done outside what everybody can see, which means people actually sit in a boardroom or enter a Zoom call, yeah, or sit down to discuss an improvement, yeah, or people actually make write a paper, the Ethereum improvement proposal, and they post it on to a particular platform for it to be approved. And that after it is approved, it goes through a number of processes before it is actually implemented. So that off-chain governance, the process through which decision-making is done on these blockchain protocols. So there is on-chain governance, and on-chain governance, most of it happens through, especially recently, most of it happens through what we call DAOs, the decentralized autonomous organizations, where the governance or the governance of a protocol have virtual identities. They have the digital identities on the blockchain, and where they're able to vote, to put a vote, yeah, for them to make a certain decision. That happens on the blockchain. But off-chain governance happens where people actually sit on boardrooms, so people actually make a call, or people actually have a Zoom call, or write a proposal for them to make a decision with regard to a decision or improvement. But even off-chain governance, when it comes to Ethereum, it involves multiple stakeholders. It involves developers. It involves the co-founders, the likes of Vitalik. It involves multiple stakeholders. Yeah, it involves multiple stakeholders. So for it is really a rigorous process, and they ensure that every improvement is really rigorous. Then we have talked about this, so I won't take much time on this. I'm just going to read them, and you're going to research more about them. We've talked about the Frontier. We've talked about the Ethereum Classic, which is the hard fork that happened after the DAO hack. The Byzantium, we've talked about that. Constantinople, yeah. The second update of the Metropolis phase, gas requirement for certain transactions were reduced, efficiency and speed of Ethereum virtual machine was improved. Yeah, so multiple improvements here, multiple Ethereum improvement proposals here that actually were implemented. Then the Istanbul, the Moa Glacier, there is also the Altair. Yeah, there is the London upgrade, there is the merge that are not included here. the ones that happened in some in 2020 and some in 2021 and 2022, the beacon chain that we've talked about. Probably you can explore those ones at your own time. Then just highlighting briefly before we move to the smart contracts quickly, the process through which we moved through before moving to the merge. Yeah. So this diagram just highlights the process. And once again, a lot of repetition here, covering whatever happened in 2020. The key activities in 2020, you look at the green line. Yeah, the green line. This really looks like some metro stations where you have the red line and the green line. So look at it jokingly like that. We have the green line here. So the green line is the one heading to proof of stake. Yeah, so you see we have the beacon chain launching there. We have the Altair upgrade. We have the data sharding. Now, sharding is an important element of this upgrade and subsequent upgrades that I think you should really study. And sharding is a matter of reducing the size of data that is stored on the blockchain per transaction. How much do we have to store? Yeah, can transactions be done? Can part of that transaction data be stored outside the non-important data? How do we reduce the size of this to make it more scalable? Yeah. So I would like to explore those ones. Then we are going to jump quickly to the Ethereum smart contracts. The traditional contracts. How does traditional contracts happen? Yeah, traditional contracts happen by an intermediary. You need a third party. You have to shake hands. You need a bank for that transaction to happen. For you to reach a contract, you need a third party. Now, smart contracts happen where, and I'm going to use this next slide to explain that. So one, how we are building the smart contracts. One, you have to write that agreement down. Yeah. What do you want to this? What do you want? What is the contract about? Are you selling something, or are you buying something, or are you exchanging some data? Yeah. What is the digital asset being exchanged? So you have to write the agreement. Then you have to decide on the conditions. What are the conditions that need to be met for this transaction to be executed, or for this agreement to be executed? Yeah. Then after writing the conditions, now code those conditions. Yeah. After coding those conditions, then you deploy them on the blockchain. Yeah. Now, once you deploy them on the blockchain, they will self-execute. Once all conditions are met, on all conditions that have been programmed or that have been coded onto that smart contract, once all that is met, they will self-execute. And that's why smart contracts are interesting. Imagine an organization where it knows that we reach an agreement where, for instance, if I do for you a certain job, you're going to pay me $1,000. Yeah. Now, the moment I complete that job, I need to call you so that you can pay me. But now in smart contracts, we reach that agreement, and that's $1,000 you deposit it into that smart contract. So when I complete the job, yeah, which is part of the condition, automatically the smart contract releases the $1,000 to my account without asking you for permission. In that case, it becomes difficult for me to call you and for you to call me. Then, of course, after it is executed, it is recorded on the blockchain. You probably need to learn Solidity language if you want to build smart contracts. Solidity is just my best option for building smart contracts on Ethereum. And I've left a link there that you can explore. Then quickly, I'm going to just share this example of a transaction on a smart contract transaction where somebody is buying a car. Yeah, you see, when you're buying a car, and the same when you're buying a piece of land or a property, a house, you need a number of people. You need a valuer, you need a lawyer, you need, when you're buying a land, you need a surveyor. So all these people that we need, you need a bank because you're going to make a transfer. So all these people that we need are what we call trusted third parties. Yeah. You cannot do major transactions without them because you do not trust the other person. But what if we can live in a world where we don't need to trust anybody? We can just transact without trust. Why? Because the system has been built in a way where we can transact without you conning me, because the system is built in a way that you cannot con me. Yeah. So assume that car is a car. It has a smart identity. It has a digital identity on the blockchain as well. So it is able, yeah, to interact on the blockchain. That digital identity is coded as well on the blockchain. Yeah. And of course, here we have to use also some other technologies, like you can involve the use of Internet of Things or AI to make it even easier. Yeah. And this is the future of transactions. This will happen in the future where they will code a digital identity into a car. Yeah. Today, it is already possible for you to hack a car when it's running and all of a sudden it stops, right? That possibility, bring it to blockchain. It will be possible for me to write a contract with you. You deposit the money, where the money that you want to pay me for the car. I deposit the documents, the ownership documents of the car onto this smart contract. Yeah. Then we deploy it into the blockchain. Yeah. Then when one of the conditions may be if I deliver the car to a certain garage. Yeah. If I deliver the car to a particular smart garage, which means that smart garage has an Internet of Things capability. It is able to communicate with the car, and these are what we call oracles. Oracles are external objects or external information being fed into the smart contract. Yeah, then it communicates to the smart contract that you have already fulfilled your condition. Then automatically the smart contract executes, and the transaction happens. Money is sent to my wallet, and the card documents are sent to your wallet. That is the future of transactions. Now, why trust smart contracts? One, important is smart contracts have no feelings. Yeah. Once we have agreed that you're selling me a car, yeah, and I've paid you the money, you need to transfer the documents. You don't go around moving around. No, I'm not going to transfer, because you can change your mind. But code is code. Yeah. Once you have coded the conditions, you are not going to change your mind because it is going to self-execute. Yeah. But now, I always say that smart contracts, the integrity of a smart contract is as good as the integrity of the code. Yeah, that's why the DAO hack was hacked in 2016. What is the integrity of the code? That's why you need to really learn well to build a smart contract without a loophole. Yeah. Then some issues with regard to smart contracts, there are legal issues. The question is a smart contract legally recognized? Yeah, probably in the future they will be. Right now, most jurisdictions still do not recognize a smart contract execution as legally. Yeah, but I believe this is something that some courts, provided you can be able to provide evidence with regard to your conditions and the agreement, court can be flexible to be able to recognize this. But legally, based on the current laws, it's not recognized. Consensus mechanism issue, how people reach consensus with regard to a particular smart contract, that is an issue of discussion. Reliance on off-chain resources, what I've talked about, where you have delivered the car to the garage and you are relying on the information from this smart garage for it to communicate to the on-chain smart contract for the smart contract to make decision. These are what we call oracles, where the smart contract has to communicate with an external environment for it to make that decision. Yeah. Then we have scalability issue. How scalable is this? How many smart contracts or how many agreements can be executed based on a smart contract? The immutability issue. The idea that it cannot be hacked. The idea that transactions on the smart contract are immutable, cannot be hacked, cannot be changed. Yeah, that is an issue as well, because we've seen certain smart contracts have been hacked. And of course, I've mentioned that is not a problem of blockchain. That is a problem of the integrity of the code. The developer who programmed that smart contract left some loopholes. Yeah, and that becomes the challenge. So I'm going to ask you to learn, go and learn Solidity. It's very important for you to explore smart contracts, because it's going to be a big thing in the future. It's going to impact most careers and most blockchain. This is the last part. A few slides. Now, we've talked extensively in the past about use cases of blockchain. We've talked about blockchain being used in digital rights. We've talked about blockchain being used in crowdfunding, in intellectual property, in voting. I told you about an example where in Sierra Leone, in Africa, in 2019, with the help of a company called Agora Blockchain, they conducted the presidential elections on the blockchain. Yeah. We've talked about digital ownership. Yeah, digital ownership. Particularly, I think we're going to expound on this in the next session when we'll cover NFTs, digital ownership or digital identity. We've talked about healthcare, how blockchain can be used in healthcare and pharmaceutical. I don't know, in Kenya, by the way, we rely on a lot of medicines, imported medicines from India and from other parts of the world. But sometimes you find there are certain counterfeit or fraudulent suppliers in the middle that just produce lookalike medicines, and then they bring them to our pharmacies. So you're taking a capsule, you're thinking that that capsule has medicine in it, when in real sense, it has dust. And you just swallow it because you just saw the cover of the capsule. Interestingly, you get well thinking that it's the medicine that made you well, yet it's probably just the placebo effect. The placebo effect is where you believe that you took medicine, therefore you get healed because you believe that you took medicine. But interestingly, that's just telling you about how many counterfeit products are in there in the world today. Now, with the help of blockchain smart contracts, we can be able to implement peer-to-peer models where the consumer and the vendor are interacting directly without having to rely on an intermediary, because the problem begins with the intermediary. The intermediary is probably charging high fees. The intermediary is easy to compromise, and a number of other things. Yeah. So when we deploy all this, when we can be able to transact on a peer-to-peer platform, yeah, on a decentralized platform, which is built or based on a smart contract like Ethereum, we can be able to implement and reduce intermediation, yeah, disintermediate all this transaction, microfinance, P2P lending, global payments, cross-border transactions. Right now, we are seeing a number of central banks across the world implementing what we call the central bank digital currencies, yeah, relying on the blockchain, yeah. And some of them, I believe, are going to depend on the Ethereum blockchain as well. Most are being built on the what do we call it? On the Hyperledger blockchain. For instance, the one for Nigeria was built on the Hyperledger blockchain. So I would like you to explore all these use cases and bring them home as to how smart contract can actually be used to create a solution for these different industries. Then this just trying to elaborate what I've already said. You look at the diagram at the top, it's telling you about now, yeah, where a buyer and a seller wanting to transact, they have to rely on a lawyer, a broker, an insurance provider, or a bank, a surveyor, all those people in the middle, the trusted third parties, yeah. But with the introduction of smart contract, the buyer is interacting or transacting directly, peer-to-peer, with the seller, yeah. And what happens? The buyer and the seller, they're at the center of it, replacing the lawyers at the validators, particularly right now in the Ethereum blockchain. These are now the validators, the distributed, independent validators who are able to actually validate whether Alice on the other side has met or fulfill all the conditions of the smart contract, and Bob on the other side have fulfilled all the transactions, all the conditions of the smart contract, then these validators make it possible for this smart contract to self-execute and gives the buyer and the seller both their rights. A good example that I would want you to go ahead and explore by yourselves because of time is Civic, the Civic platform. Yeah. And I've added a link at the end of the resources, a link that will take you to several other use cases of blockchain, actually not use cases, but case studies, yeah, platforms that have been built on the Ethereum blockchain using the smart contracts, yeah, that you will be able to explore at your own time. So Civic is an interesting project that I learned about some years back. It makes it possible for you to have multiple credentials, yeah. Now, one of the greatest use cases of blockchain today is digital identity. Yeah, the reason is because stealing identity, where somebody steals your identity. I travel with your passport. Yeah, I'm traveling as I go out there and I'm traveling as I'm going to travel, for instance, as Felix Isaiah, or traveling as presenter. Yeah. Yet I'm really not you, but I have all the documents produced. That is digital stealing your identity. Now, it has gone to the level where I can steal your digital identity. I can be able to communicate with your email. I can be able to communicate with your identity, thinking that you are me. Another problem with identity is that if I do not have a nationally recognized or an internationally recognized identity, I am not able to open a bank account. I am not able to interact with regulated platforms, yeah? And that becomes a problem. So with digital identity based on the blockchain, we can be able to transact and interact with other platforms. And I would like you to, there's a number of websites that you can be able to explore. The number one of them is the ethereum.org. Yeah, ethereum.org. You are going to explore multiple aspects of Ethereum. Yeah, if you're a developer, whether you're a programmer, whether you want to learn about smart contracts, you are going to learn a lot on the ethereum.org platform. Yeah, then I've also added the link to civic.com that you can be able to explore Civic. I've added a number of, I've added that link from Consensus that gives you 90 Ethereum applications, yeah, that you can use right now. 90 Ethereum applications that are built on Ethereum that are actually live, yeah. I've also added a link with regard to the upgrades, yeah, and several other links there. I've added a link to Udemy course, to a Coursera course, yeah. The link as well to the Blockchain Training Alliance. There are several other platforms where you can be able to learn Ethereum. And that marks the end of our session today. I think I'm going to check on the questions. Okay, Gupta, what are the characteristics you kept in mind while choosing Ethereum over similar types? I guess what you mean is I guess what you mean here is what are the features of Ethereum that made me choose Ethereum as opposed to other networks? Okay, of course, when choosing which platform to build a smart contract, number one is the friendliness of that protocol. Yeah, how the developer support or developer tools. Yeah, 2, community. Yeah. 3, consensus protocol. Yeah, the security of that protocol. How secure, how tested is that protocol? Yeah, of course, you have to look at fees. Ethereum fees is higher, of course, than platforms like Binance Smart Chain. However, there are trade-offs. You may look at what is the security, the community with regard to, the developer community with regard to smart contracts. Which one is bigger? Which one will favor the project that you want to do? Yeah. So there are projects that I would advise you to build on Ethereum blockchain, but there are projects that I would advise you to build on the Binance Smart Chain. As well, there are projects that I would advise you to build on the Celo, yeah, the Celo blockchain, yeah. There are other projects there are different projects that best fit different platforms, yeah. So it depends with what you want to build and what are the features. Can you provide any such links? I think I've provided those links. What are T3? I think you're talking about the image on governor. That is Tezos, eh? Then is data sharding the same as data? Data sharding, no, data sharding, of course, data sharding has the word data, so it can't be the same as data. Yeah, data sharding has the word sharding. Sharding is, in layman terms, I can call it reducing weight. Yeah, if I'm too fat, if I'm weighing 100 pounds, how can I reduce my weight to say 50 pounds? Yeah, I'm sharding, I'm reducing, I'm becoming lightweight. Yeah, so a lightweight data on the network makes it more scalable, makes it easy for transactions to be held on that network. Yeah, it probably makes it more efficient. Yeah, so that is an important development in both blockchains. Even on the Bitcoin blockchain, the discussions around the Lightning Network, but particularly on the Ethereum blockchain, the discussion about data sharding is a developing discussion that you can explore further. Then you asked about, is the Oracle spelled the same way? Yes, the word Oracle is spelled as you have just spelled it there. Oracle. Oracles, external information sources that feed that feed the blockchain. Then I'm seeing other, I don't know, these are just communications are not questions, developer support, community, cost of gas, and all that. Okay, all right, those are not. Well, I guess those are the only questions. Back to the host.
Thanks a lot, Benjamin. On behalf of Analytics Vidya, I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. LinkedIn profile of the speaker is in the chat, and I hope you guys have filled in the feedback poll. If not, I request you to please fill in the poll about feedback, as it helps us to conduct more such sessions. If you wish to conduct a webinar or are facing difficulty in registering, connect with us at editor@analyticsvidya.com. The recording of the session will be available within 2 days on our YouTube channel, and the link will be in the description. We'll be back with another data session on on 21st of Jan. The link is in the chat section. Till then, bye-bye and keep learning.